In the vast velvet theatre of the cosmos, silence is not empty. It is a heavy, peaceful blanket that covers everything. It is a sonnet that has existed for billions of years, older than the mountains on Earth, older than the oceans. In this deep, quiet time does not tick like a clock. It flows like a slow, dark river. It is October 29, 2025. Far away from the blue skies of our home planet, out in the deep black void, a traveller is reaching the climax of a very long journey. This traveller is the comet known to astronomers as 3I Atlas. For ages, it has been drifting through the freezing cold, a lonely mountain of ice rock and ancient dust. It has been sleeping dormant and still tumbling slowly through the endless night. To an observer, it would look like a rough, dark stone, lifeless and cold. But today the sleep ends. Today is the day of the awakening. The comet is approaching a specific point in space called Perihelion. This is a beautiful word that simply means the point in the orbit, where the comet comes closest to the sun. Imagine a moth flying closer and closer to a bright lantern in the dark. For 3I Atlas, the sun is not just a light. It is a colossal furnace, a roaring beast of pure energy. As Atlas glides closer, the environment changes drastically. The absolute zero cold of deep space begins to surrender to a searing, intense heat. This is the moment of tension. It is the calm before the storm. There is a profound contrast here that is hard for the human mind to fully grasp. On one side, there is the vacuum of space, completely silent. There is no wind to howl, no sound of burning, no crash of thunder. There is only perfect stillness. On the other side, there is the violent, invisible force of solar radiation slamming into the icy surface of the comet. The heat begins to work its magic. It does not happen all at once, but it happens with a sudden, powerful acceleration. The ice that has been frozen solid for eons begins to sublimate. This means it turns directly from a solid block of ice into a gas, skipping the liquid stage entirely. It is like a sigh of steam released from a hot kettle, but on a massive celestial scale. Deep inside the heart of the comet, the pressure builds. Pockets of gas trapped since the birth of the solar system suddenly expand. They push against the crust of rock and dust. The sleeping mountain begins to tremble, not with fear, but with energy. It is reacting to the sun's embrace. Then the moment arrives, the brightness surge. On Earth, scientists and astronomers were watching their monitors, expecting a beautiful display. They had done the math. They had calculated how much ice would melt and how much light the comet would reflect. They expected a bright star in the darkness. But the universe loves to surprise us. It loves to show us that nature is wilder and more powerful than our calculators can predict. 3 Atlas did not just glow, it erupted with light. In a breath of cosmic time, the comet released a massive cloud of dust and gas. This cloud, called a coma, expanded rapidly around the solid core. It acted like a giant mirror, catching the sunlight and scattering it in every direction. The prediction was shattered. The brightness did not just double or triple, it surged to 7.5 times the expected intensity. Imagine walking into a dark room and expecting a single candle to be lit, but instead a stadium floodlight turns on. That was the magnitude of the change. Yet the most mesmerizing part of this event is the silence. If you were floating right next to it watching this explosion of gas and light, you would hear absolutely nothing. The huge jets of steam bursting out would make no sound. The cracking of the rocky surface would be mute. It is a silent fireworks show of epic proportions. It is a violent transformation wrapped in total peace. The tail of the comet unfurled like a brilliant fan behind it, stretching for millions of kilometers, painting a streak of silver across the black canvas. The dust particles freed from the ice danced in the solar wind, sparkling like diamonds. The comet, once a dark and invisible rock, had transformed into a beacon. It was shouting its existence to the universe, not with sound, but with pure, blinding luminance. This event, this sudden brightness surge, reminds us of the power of light in the darkness. It represents a sudden clarity, a moment where potential energy turns into kinetic beauty. The awakening of 3I Atlas was a surprise gift to the solar system. It showed us that even in the most predictable orbits, the unexpected can happen. The surge was brief in the grand scheme of the universe, but for those watching it was a spectacle of physics and art combining. The comet survived its brush with the fire, changed forever lighter than before, leaving a trail of itself behind as a memory. As the event peaked, the comet began its swing around the sun, ready to head back out into the cold. But in that moment of perihelion, in that flash of brightness, 7.5 times stronger than we dared to dream, it proved that the universe is alive with energy. It proved that even the coldest, darkest things can shine brilliantly when they get close to the source of light. The awakening was complete. The silent explosion had painted the dark with silver, a masterpiece created in a single breathless moment of heat and ice. Imagine holding a stone in your hand. It feels heavy, solid, and perhaps a little cold. Now imagine that this stone is not from a riverbed or a mountain on Earth. Imagine it is the traveller we are following drifting through the absolute silence of space. To understand this traveller, we must first understand the sheer overwhelming scale of its age. This is not just an old rock, it is a relic from the dawn of everything we know. Scientists estimate that this interstellar object is somewhere between 7 billion and 12 billion years old. When we see numbers like that written down, they can feel abstract, like just another math problem. But let us pause and truly feel the weight of those words, 12 billion years. To put this into perspective, we need to look at our own home. Our sun, the golden star that gives us life, is about 4.5 billion years old. The Earth formed shortly after that. This means that our celestial traveller was already wandering the dark corridors of space long before our sun was even born. It was already old when Earth was just a cloud of dust and gas. It was drifting in silence before the first oceans formed on our planet, before the first single-celled life appeared, and billions of years before the first dinosaur took a breath. When you look at this object, you are looking at something that remembers a version of the universe that no longer exists. This traveller comes from a time when the Milky Way galaxy was young and chaotic. In those early days, the universe was a much more violent place, and stars were being born in explosive bursts of light, and giant planets were shifting their orbits, crashing into each other like cosmic billiard balls. It is likely that during one of these chaotic dances, our traveller was kicked out of its home system. A giant planet, perhaps one that doesn't even exist anymore, used its gravity to fling this object away, sending it rushing into the darkness. And so the lonely journey began. For billions of years, it has floated through the interstellar medium. This is the fancy name for the vast, empty space between the stars. We often think of space as empty, but it is actually filled with a very thin soup of gas and dust. However, the distances are so vast that for millions of years at a time, this object would see nothing but darkness. It would not feel the warmth of a star, it would not feel the pull of a planet. It would just be, imagine the solitude. There is no sound in space. For eons, the only companion this traveller had was the silence. It drifted past nebulae, giant glowing clouds of purple and red gas where new stars were being knitted together. It watched these stars ignite, burn bright blue, and then eventually die, turning into dark cinders. It saw solar systems form spin for a few billion years and then fade away. And through it all, the traveller kept moving, preserving its momentum, a silent witness to the history of the galaxy. This is where the concept of deep time becomes beautiful rather than scary. Deep time is the idea of geological or cosmic time that is so long it is almost impossible for a human mind to grasp. Usually this makes us feel insignificant. We live for maybe 80 or 90 years, which is less than a blink of an eye to this stone. But there is a great comfort in this smallness. When we think about this traveller enduring for 12 billion years, our daily worries, the deadline at work, the traffic jam, the awkward thing we said at dinner, suddenly feel very light. The universe is not in a rush. This object did not rush to get here. It did not panic when it spent 100 million years in total darkness. It simply waited. It trusted the laws of physics to carry it forward. It possesses a kind of patience that we can learn from. In our modern world, everything is instant. We want answers now. We want to arrive now, but the traveller teaches us the art of endurance. It teaches us that the journey itself is the point. Think about the conditions it survived. It has been frozen to temperatures near absolute zero, hundreds of degrees below freezing. It has been bombarded by cosmic rays, which are high-energy particles that zip through space like tiny bullets. It has tumbled through the void, turning over and over in the blackness. Yet it remains. It is scarred, pockmarked and strange-looking, but it is whole. Whole, it is a survivor. There is a specific kind of peace in imagining this journey. Close your eyes for a moment and picture yourself drifting alongside it. There is no wind to push you, no gravity to pull you down. You are just floating. The stars are not twinkling because there is no atmosphere to distort their light. They are steady, piercing points of diamond light against a velvet black background. You're moving at thousands of kilometers per hour, yet because there is nothing nearby to pass, it feels like you are perfectly still. This is the paradox of the traveller. It is moving incredibly fast, yet it is completely at rest. It is homeless, yet the entire galaxy is its home. As it travelled through the spiral arms of the Milky Way, it likely passed through regions of space that are crowded with stars and regions that are desolate and empty. It might have passed by systems with planets like ours, perhaps even planets with life that rose and fell while the rock just kept drifting by. It is a ghost of the galaxy, passing through walls unseen and unheard. When it finally entered our solar system, it was the first time in eons that it felt the significant warmth of a star. As it approached our sun, the layers of ancient ice deep beneath its surface began to wake up. For the first time in billions of years, it felt a summer, but it did not stay. It did not get captured by the sun's gravity to settle down and become a comet or an asteroid in our neighbourhood. It kept its independence. It swung past the sun, gathered a little more speed, and headed back out toward the exit door. This brief visit is what makes the object so poetic. It connects the deep time of the past with our specific moment in the present. Out of all the billions of years it has travelled, and out of all the infinite directions it could have gone, our timelines intersected. We were here with our telescopes and our curiosity at the exact moment it flew by. It reminds us that while we are small, we are also incredibly lucky. We are the universe experiencing itself. We are the eyes that get to witness the traveller. Even though our lives are short compared to the 12 billion year lifespan of this object, we have the ability to wonder, to dream, and to feel a connection to this ancient rock. So as you think about this traveller returning to the deep darkness of interstellar space, let it bring you a sense of calm. The universe is vast, old, and patient. It has room for everything, for the birth of stars, for the drifting of ancient stones, and for you. Your problems are temporary, but the peace of the cosmos is eternal. Like the traveller, you can endure the cold moments and the dark moments, knowing that you are part of a grand, beautiful, and ancient story that is still being written one quiet mile at a time. Imagine, if you will, standing in a vast, completely dark room. It is so silent that you can hear your own heartbeat. Suddenly a single clear note is played on a piano somewhere in the darkness. Even without seeing the pianist and without seeing the instrument, your ears immediately understand the reality of the situation. You can tell if the note is high and sharp or low and rumbling. You can identify the instrument as a piano and not a violin. In the boundless silent ocean of space, we cannot hear sound. Sound requires air to travel, and space is a vacuum, but the universe is not quiet. It is constantly singing to us, not with sound waves, but with light waves. To understand the green comet, and indeed to understand the cosmos, we must learn to listen to this silent music. We must learn the language of spectroscopy, the rainbow code. When we look at the green comet through a standard telescope or a pair of binoculars, our eyes perceive a fuzzy, glowing emerald ball. It is beautiful, but it looks simple. However, to an astrophysicist, that green light is a complex encoded letter waiting to be read. To decode this letter, scientists use a method called spectroscopy. Think of white sunlight as a magnificent choir where everyone is singing at once. To our ears or eyes, it sounds like one unified note. But if you pass that white light through a prism, a special triangular piece of glass, the choir is separated. The light spreads out into a fan of colours ranging from deep red to vibrant violet. This spread of colours is called a spectrum. Here is the magical part. Every element in the periodic table, hydrogen, helium, carbon, nitrogen, oxygen, has a unique fingerprint. When these elements are heated up or energized, they do not emit every colour of the rainbow. They only emit very specific colours appearing as bright lines on the spectrum. It is exactly like a barcode on an item in a grocery store. If we see a specific pattern of lines in the light coming from millions of kilometres away, we know with absolute certainty what molecules are present there. We do not need to travel to the comet to take a physical sample. The light carries the sample to us across the void, the green symphony carbon and nitrogen. So when astronomers took the light from this specific green comet and spread it out into a spectrum, what did the barcode tell them? They saw a very strong, distinct song being sung by two specific characters, carbon and nitrogen. Specifically, the green glow is caused by a molecule known as diatomic carbon. In scientific notation, we use symbols, but in plain English, you can simply visualize this as two carbon atoms holding hands. These are not the stable carbon atoms you might find in a piece of coal or a diamond. These are pairs of atoms floating in the gas around the comet. When the sunlight hits the comet, it acts like a trigger. The ultraviolet rays from the sun strike these pairs of carbon atoms. This energy makes the atoms vibrate and dance. As they relax back down from this energetic dance, they release the extra energy in the form of light. The specific energy required for diatomic carbon to relax corresponds exactly to the green part of the visible light spectrum. This phenomenon is called molecular emission. Alongside the carbon, there is often another molecule called cyanogen. This is a combination of one carbon atom and one nitrogen atom. Like its partner, cyanogen also loves to fluoresce or glow in blue and green shades. This creates a fascinating paradox in our visual imagination. If you were an astronaut standing right next to the nucleus of the comet, the solid center, it might look black or dark grey like a dirty soball, but the gas surrounding it, the coma, is glowing like a neon sign in a city window. The sun acts as the electricity, and the carbon and nitrogen gases act as the neon tubes, lighting up the dark with a ghostly vivid emerald colour. The absence of dust and the presence of gas. You might find yourself wondering, aren't all comets usually white? It's a very good question. Many of the famous comets we see in history books or photographs, like Halley's Comet, often appear white or yellowish. This colour comes from dust. Think of driving down a dry dirt road in the middle of summer. If you shine a flashlight onto the road, the dust kicks up and reflects the white light of your beam back at you. When a comet releases a massive amount of dust, that dust acts like millions of tiny mirrors reflecting the sunlight. Since sunlight is white, the comet appears white to our eyes. However, our green comet is different. It is what astronomers describe as gas-rich and dust-poor. It is not releasing thick clouds of dust to reflect the sun. Instead, it is releasing distinct gases, because there isn't a thick fog of dust to reflect the white sunlight and overpower the view. We are left with the pure, unadulterated glow of the gas itself. It is the difference between a bright lamp shining through a fog, which looks white and diffuse, and a glow stick snapping in the dark, which looks vivid and coloured. The absence of dust allows the invisible colours of the chemical reactions to take centre stage. It allows the comet to show its true chemical colours. The blue shift. A cosmic approach. There is one more secret hidden in the whispers of this light, and it tells us about movement. To understand this, we must think about sound again. Have you ever stood on a sidewalk when an ambulance drives past with its siren blaring? As the ambulance drives towards you, the siren sounds high-pitched and urgent. The moment it passes you and drives away, the sound instantly drops to a lower, deeper pitch. This is called the Doppler effect. Sound travels in waves. When the ambulance moves towards you, it squashes the sound waves together, making them shorter, higher pitch. When it moves away, it stretches the waves out lower pitch. Light behaves in a very similar way because light also travels in waves. Red light has long, lazy, stretched out waves. Blue light has short, energetic, compressed waves. If a star or a comet is moving away from Earth, its light waves get stretched out behind it. The light appears slightly redder than it should. We call this a red shift. But if an object is rushing towards us, the light waves get squished together in front of it. They become shorter. They shift towards the blue end of the spectrum. This is called a blue shift. When scientists analyse the light from this comet, they could measure this tiny shift in the position of the spectral lines. The wavelength of the light was slightly compressed. This confirmed that the comet was not fleeing into the dark outer edges of the solar system. It was travelling inward, approaching us and the warmth of the sun. The blue shift acts as a cosmic speedometer, telling us the direction and speed of this celestial traveller. The beauty of the invisible. There is a deep sense of relaxation to be found in understanding these mechanics. When we look up at the night sky, we are not just seeing static, dead points of light. We are seeing a dynamic, living conversation that spans the galaxy. The light acts as a courier carrying packages of information across the millions of kilometers of void. It whispers to us, "I am made of carbon and nitrogen." It whispers, "I am glowing because the sun is touching me." It whispers, "I am moving towards you." We human beings have eyes that are quite limited. We only see a tiny sliver of reality, which we call visible light. But through the tools of science, we have expanded our senses. We can now see the chemical composition of a snowball flying through space. We can read the air of a world we will never visit. Think of the comet not as a rock, but as a traveller singing a song. For thousands or even millions of years, it hummed quietly in the frozen dark of the outer solar system. Now, as it steps into the spotlight of the sun, it bursts into a chorus of green. It is a gentle reminder that the universe is full of colour and beauty that exists even when we aren't looking. The carbon atoms do not glow for us. They glow because that is their nature. They simply are. And in that simple existence, in the dance of atoms and the vibration of wavelengths, there is a perfect silent harmony. We are just lucky enough to be here to witness the show. As we continue our journey through the silent, frozen reaches of the outer solar system, we shift our gaze from the chaotic collision that created the moon to the quiet, enduring aftermath. We are looking at the surface of Charon, but more specifically, we are looking at its skin. When you look at images of this distant moon, you notice something striking. It is not a uniform ball of white ice. At its northern pole there is a dark reddish-brown stain. It looks like a cap or perhaps a bruise. Scientists call this region Mordor Macula. But in the context of our story, it is something far more poetic. It is a shield. It is a callus formed by the universe itself. This is the story of the radiation-processed crust, the invisible sculptor, cosmic rays. To understand this armor, we must first understand what is happening in the empty space surrounding Charon. The universe is not truly empty. It is filled with invisible energy. We call these cosmic rays. Imagine these cosmic rays not as destructive lasers, but as a constant gentle rain of tiny high-speed particles. Some come from our own sun carried on the solar wind. Others come from much farther away, from exploding stars and violent events deep in the galaxy, travelling for millions of years before they reach our solar system. On Earth, our atmosphere and magnetic field protect us from this rain. But Charon has no such bubble. It sits naked in the dark. For billions of years, these cosmic rays have been raining down on its surface. This process is slow. It is unimaginably slow. It is a sculptor that takes 1 billion years to make a single cut. When these high-energy particles hit the simple ice on the surface, mostly methane and nitrogen that escaped from Pluto and settled on Charon, they trigger a change. They break the chemical bonds holding the ice together. It is like a very slow form of baking. The cosmic rays strip away the hydrogen from the methane, leaving the carbon behind. Over eons, these carbon atoms find each other and link up, forming long, complex chains. They transform from simple clear ice into heavy, sticky organic materials. Scientists call these materials tholins. In our relaxing view of the universe, think of this as a cosmic tan. Just as your skin darkens to protect you from the sun, Charon's pole has darkened over eons. The radiation has processed the crust, turning it into a hard reddish shell. It is the physical evidence of time passing. It is a protective layer built by the very harshness of space. James Webb and the breath of the moon. For a long time, we could only guess what this red armor was made of. We looked at it with older telescopes and saw only the color. But recently, humanity opened a new eye to the universe, the James Webb Space Telescope. James Webb is special because it sees the universe in infrared, the type of light associated with heat and chemical fingerprints. When James Webb turned its golden mirrors toward Charon, it looked deeper than we ever had before. It looked past the glare of Pluto and focused specifically on the chemical composition of this frozen moon. What it found was a revelation. James Webb detected the clear signature of carbon dioxide and hydrogen peroxide trapped within and under this radiation-processed crust. Why is this exciting? Because it tells us a story of preservation. The carbon dioxide acts as a time capsule. It suggests that underneath that tough, radiation-baked outer shell, there is a reservoir of primordial material stuff that has been there since the very birth of the solar system. The armor of starlight has done its job. It has taken the beating from the solar wind and galactic radiation so that the material beneath could stay safe. The discovery of hydrogen peroxide is equally fascinating. On Earth, we use it to clean wounds. On Charon, it is likely created when water ice is broken apart by its upcoming radiation. It is a sign that the surface is alive with chemical activity, even in the freezing cold. It shows us that this moon is not a dead rock. It is a chemical laboratory that has been running an experiment for 4 billion years. The philosophy of the crust. A safe shelter. Now let us take a step back and feel the relaxation angle of this scientific phenomenon. In our daily lives, we often view weathering as a bad thing. We paint our houses to stop the paint from peeling. We use creams to stop our skin from wrinkling. We fear the marks of time. But in the cosmos, weathering is a form of strengthening. The radiation-processed crust of Charon teaches us a beautiful lesson about resilience. Imagine standing on the surface of Charon. It is quiet. The sun is just a particularly bright star in the distance. You are surrounded by the absolute cold. But you are standing on a layer of history. This red crust is not damage. It is a blanket. The shield. The outer layer absorbs the energy of the universe. It changes its form, darkening and hardening to create a barrier. Because the crust exists, the ice deep below remains pure and untouched. The shelter. Think of this crust as a roof over a house during a storm. The storm of radiation has been blowing for billions of years, but the roof holds. It provides a safe shell, the beauty of imperfection. A perfectly white, smooth ball of ice would be boring. It would tell no story. The red stain on the pole tells the story of survival. It says, I have been here, I have endured the solar wind. I have caught the escaping atmosphere of my neighbour Pluto, and I have made it my own. There is a deep sense of peace in this. It reminds us that transformation is natural. The universe does not destroy things without creating something new in the process. It took methane, a simple colourless gas, and turned it into Tholin's complex, colourful organic compounds that might even be the building blocks of life elsewhere. Transformation in the dark. The creation of this armour is the ultimate act of patience. It is a reminder to us to slow down. The sculpting of Charon did not happen in a day or a year or a human lifetime. It happened drop by drop, particle by particle. When we feel rushed or pressured by the fast pace of our modern world, we can think of the northern pole of Charon. We can think of the carbon dioxide resting quietly beneath that red blanket, safe and sound. We can appreciate the slowness. The radiation did not break the moon, it forged it. It turned a vulnerability being exposed to space into a strength, a hardened, chemical-rich surface. Summary of the armour. As we conclude this part of our observation, we are left with a new appreciation for the dirty parts of space. We see that cosmic rays are the invisible artisans slowly changing the chemistry of everything they touch. The crust is a result of this interaction, a radiation-processed layer that acts as both a history book and a shield. James Webb has allowed us to read this history book, finding carbon dioxide and hydrogen peroxide, confirming that complex chemistry happens even in the coldest shadows. Protection is the ultimate theme. The universe provides a way for objects to endure. The starlight and radiation over time build a suit of armour for the moon. We leave Charon now, having seen its scars and understanding them as marks of beauty and survival. We move forward carrying this sense of cosmic protection with us. There is a hidden architecture to the universe, a silent framework that we cannot see with our eyes, but can feel with our minds. When we look up at the night sky, we see points of light scattered like diamond dust across a velvet canvas. But if we could put on a different pair of glasses that let us see gravity, momentum, and time, the sky would look very different. It would look like a vast ocean of curved spirals and gently sloping valleys. This is the invisible geometry of space, and our visitor 3i Atlas is currently tracing one of the most fascinating lines through this great design. Usually when we think about things moving in space, we think of circles. The Earth circles the Sun, the Moon circles the Earth, even the Sun circles the centre of the Milky Way. Everything is spinning, caught in a never-ending loop like dancers holding hands. It is a comforting, repetitive rhythm. But 3i Atlas is different. It does not want to dance in a circle. It is a traveller, a nomad, and its path is a rare and beautiful thing, a hyperbola. Getty Images. In simple language, this means 3i Atlas is not here to stay. It is not getting caught in the sun's trap. Its trajectory is surprisingly flattered and strangely straight compared to the loops of the planets. Imagine a frozen lake where everyone is skating in circles near the centre. Then suddenly one skater glides in from the far edge, cuts a perfect straight line right through the middle of the crowd and continues out the other side without ever slowing down. That is 3i Atlas. It is following a path that was decided billions of years ago, a line drawn by the initial push it received when it was born. The angle of this path is what makes it so special. It is not moving along the same flat plate as Earth and Mars. It is diving in at an angle piercing through our solar system like a needle through fabric. There is a clean mathematical perfection to this. It reminds us that nature is the greatest artist of all. The comet does not need an engine or a steering wheel. It simply surrenders to the laws of physics. It trusts the geometry. There is a deep relaxation in that idea, the idea of just letting go and letting the natural current carry you exactly where you need to be. Now let us talk about the speed of this drift. It is moving at a velocity of roughly 130,000 miles per hour. It is hard to even imagine a number that big. To give you an idea, that is vastly faster than a speeding bullet. It is faster than any jet plane we have ever built. If you could travel that fast, you could circle the entire Earth 5 times in just 1 hour. However, here is the beautiful paradox. Despite this incredible speed, if you were watching 3i Atlas from a window, in a spaceship it would look perfectly still. It would not look like it was rushing or hurrying, because space is so large and empty. There is no wind to rush past your ears, no blurring of the scenery. There is only a smooth, silent glide. It is the ultimate flow state. It is moving with absolute purpose, yet it is completely at peace. It teaches us that being fast does not mean being stressed. You can move with great power and speed while remaining calm and centered inside. Where did this silent traveler come from to answer that we have to cast our minds back, far back to the galactic frontier? The calculations of its orbit suggest that 3I Atlas came from the very edge of the Milky Way, perhaps formed when our galaxy was still very young. It is a relic from the dawn of time. Imagine the fringes of the galaxy, a place where the stars are thinner, looking out into the deep black void of intergalactic space. This is the suburbs of the Milky Way. It is quiet there. It is cold. And from that distant lonely shore, a piece of ice and rock began a long, long journey. It has been falling toward us for millions of years. It has drifted past dead stars and nebulae where new stars are being born. It has seen the silence of the void for eons. This origin story gives the comet a feeling of wisdom. It is like an old grandfather walking through a playground of children. The planets in our solar system are busy and energetic, constantly spinning and interacting. But 3I Atlas carries the stillness of the galactic edge. It brings with it the memory of the early universe. It is a time capsule that has been sealed for billions of years, and now for a brief few months it's opening its secrets to us. There is something incredibly soothing about contemplating this invisible geometry. In our daily lives, we often feel like we are fighting against obstacles. We feel like we have to push and force things to happen. We worry about taking the wrong turn. But looking at the path of 3I Atlas reminds us that there is a natural order to things. The comet does not worry about where it is going. It does not doubt its path. It follows the curve of gravity with total faith. The math that guides this comet is the same math that shapes a flower petal, the same math that spirals in a seashell, and the same math that determines how water flows down a river. It is a universal language of harmony. When we look at the straight, flat trajectory of this visitor, we are seeing the bones of the universe. We are seeing the structure that holds everything together. Think of the comet not as a rock, but as a drop of ink falling into a glass of clear water. It creates a shape, a streak, a beautiful form that changes moment by moment. 3I Atlas is painting a line through the dark. Even though we cannot see the line with our eyes, we know it is there. It is a line of energy, a line of history. As it passes us at 130,000 miles per hour, it does not disturb the Earth. It does not crash into us. It simply waves hello from a distance and continues on its way. It is a brief encounter between two travelers in the night. We are on our loop and it is on its line. We meet at the crossroads, share a moment of silent acknowledgement, and then part ways. So as you visualize this segment of the comet's journey, let yourself relax into the concept of the trajectory. Think of your own life not as a chaotic mess, but as a smooth curve through time. You too have a momentum. You too are guided by invisible forces of environment and history. There is a comfort in knowing that you do not always have to steer. Sometimes you can just be like 3I Atlas. You can trust your velocity, you can trust the flow. You can let the invisible geometry of life carry you forward smooth, fast and silent, drifting towards your own destiny with the grace of a star traveller. The comet eventually heads back out toward the blackness, returning to the deep freeze of the galactic frontier. It will not come back this way again. This moment right now is unique. It is a singular point on a graph that stretches out for infinity. And we are here to witness it. We are here to appreciate the beauty of the straight line in a universe of circles. We are here to feel the rush of the speed and the peace of the silence all at the same time. As we journey deeper into the heart of this cosmic event, we arrive at the moment of absolute transformation. This is not merely a physical change, it is a liberation. The comet, which has travelled in a frozen slumber for billions of years, is now reacting to the warm touch of the sun. This process is called sublimation. To understand this mechanism, imagine a piece of ice on Earth. If you leave it out on a warm day, it melts into a puddle of liquid water, and eventually that water evaporates into the air. But in the vacuum of space, the rules are entirely different. There is no liquid stage here, there is no melting into puddles. The environment is too extreme and the pressure is far too low for liquid to exist. Instead, the ice undergoes a magical leap. It transforms directly from a solid rock-hard block into a gas. It skips the middle step entirely. It is a sudden ghost-like transition. The solar energy strikes the surface and the water molecules, which have been locked tightly together in a rigid embrace since the dawn of the solar system, are suddenly given the energy to break free. They vibrate, they shake, and then, in an instant, they let go of one another. They launch themselves outward, expanding into the vast emptiness. This is sublimation, the direct flight from captivity to total freedom. But why does this happen with such explosive force? Why is it not a gentle, steady drift? The answer lies beneath the surface. The comet is not just a uniform ball of ice, it is covered in a crust. This crust is a complex mixture of dust rock and dark organic material, a shell that has protected the icy interior for eons. As the sun warms the comet, the heat penetrates this dark outer layer and reaches the volatile ices hidden underneath, specifically the carbon dioxide and water ice. Think of a pressure cooker or a bottle of sparkling soda that has been shaken vigorously. The gas inside wants to get out. It pushes against the walls of its container with increasing desperation. Inside the comet, the solid ice turns to gas, but it is trapped beneath that dirty, hardened crust. The pressure builds relentlessly. It pushes and pushes, seeking a weak point. The gas expands, trying to take up much more space than the solid ice ever did. It needs room to breathe. The tension rises. The ancient crust groans under the strain. It can no longer contain the massive energy building up inside. Then the failure occurs, the crust cracks. It's not a failure in the sense of a mistake. It is a magnificent structural surrender. The shell fractures and the great unfolding begins. This is the moment the comet truly comes alive. Jets of gas and dust burst through the fissures in the surface. It is a violent yet beautiful expulsion. The carbon dioxide acts like the propellant, the initial push that shatters the lock, but it is the water that follows in a glorious torrent. The sheer scale of this release is difficult to wrap our minds around, yet we must try to visualize the numbers to appreciate the grandeur. Scientists have measured this output. At the peak of its activity, this body of ice releases an astronomical amount of water. We are talking about a quantity described as 1.36 times 10 to the power of 27 molecules every single second. Let us pause to really think about that number. 1.36 times 10 to the power of 27. That is the number one followed by 27 zeros. It is a quantity so vast it becomes abstract to the human mind. To put it in a more relatable perspective, imagine all the water rushing over the edge of the largest waterfalls on Earth, Niagara, Victoria, and Iguazu combined. Now imagine that massive volume of water turning instantly into a shimmering cloud of steam, expanding endlessly into the black sky. Every second, billions upon billions of tons of potential water are cast out into the void. It is a river of stars, a flood of vapor pouring out from the heart of a tiny rock. From a relaxing perspective, try to visualize this scene, not as an explosion of destruction, but as a blooming flower or a release of tension. Close your eyes and picture a stream of water flowing in slow motion. In space, there is no gravity to pull the water down. There is no down for the water to fall toward. So the water molecules do not crash into a riverbed. They dance. They spiral outward in a wide, glowing fan. Imagine you're watching a pot of water boil on a slow, lazy afternoon. You see the steam rising, twisting and curling in the sunlight coming through the kitchen window. Now magnify that steam until it is the size of a mountain. Magnify it until it is the size of a planet. The sunlight hits these tiny molecules of water and dust and they glow. They catch the light, creating a halo of brilliance around the dark center of the comet. This is the coma, the atmosphere that the comet creates for itself. It is a waterfall that flows in all directions at once. It is a fountain of diamonds. Each molecule is a tiny crystal reflecting the pure light of the sun. It is a silent symphony. In the vacuum of space, there is no sound. This massive eruption, this tearing of the crust and rushing of gas, happens in absolute sense. It is a peaceful chaos. The energy is intense, but the visual is serene. It looks like a soft white veil being lifted from the face of the comet. This phase change from solid to gas is one of the most fundamental processes in the universe, and here we see it on a grand stage. It is the universe breathing. The comet exhales, and in that breath it releases the ingredients of life. We must remember that this is water, the same substance that fills our oceans, falls as rain, and runs through our veins. Before it was liquid water on Earth, it might have been gas and ice in a comet like this one. The Great Unfolding is the story of water being gifted to the cosmos. As the molecules rush away at speeds of hundreds of meters per second, they form a long trailing tail that stretches for millions of miles behind the comet. This tail is essentially a river of steam and dust painted across the canvas of the solar system. It is a reminder of the deep connection between the freezing cold dark of deep space and the warm, wet environment of our home planet. Watch the steam rise in your mind's eye, feel the sense of release. Just as the comet lets go of the pressure it has held for billions of years, there is a lesson in relaxation here. The tension is released not with anger, but with a natural, inevitable flow. The ice does not fight the sun. It accepts the energy and transforms. It changes its state. It becomes lighter, freer, and more expansive. It occupies more space. It becomes visible to the rest of the universe. The breaking of the crust is the breaking of barriers. The number 1.36 times 10 to the power of 27 is not just a dry statistic. It is a testament to abundance. It shows us how much potential is stored inside even the smallest, coldest objects, waiting for the right moment, the right warmth to unfold and reveal itself. It is a cascade of white mist in the eternal night, a bridge between the solid and the ethereal, a grand, silent gesture of letting go. In our journey through the cosmos, we often look for things that shine in the dark. We look for stars twinkling in the black void or galaxies glowing faint and far away. But there is a strange paradox in our solar system. Sometimes the hardest place to look is right where the light is brightest. This brings us to a phenomenon that frustrates astronomers and spacecraft engineers alike. It is the challenge of looking at or behind the master of our system, the Sun. The blinding wall of light. Imagine you are standing in a dark field and someone shines a powerful spotlight directly into your eyes. Can you see the person holding the light? Can you see the trees behind them? No. You are blinded by the glare. The light that usually helps you see is now the very thing preventing you from seeing. This is exactly what happens in space. The Sun is so incredibly bright and powerful that it creates a zone of invisibility around it. When a planet, a comet, or a spacecraft moves behind the Sun from our perspective on Earth, it enters what we call a solar conjunction. For weeks at a time, the Sun acts like a massive curtain. It is not a curtain of darkness, but a curtain of blinding energy. During this time, objects are hidden from our view. We cannot see them with standard telescopes because the Sun's light would damage the sensitive lenses, just as staring at the Sun would hurt your human eyes. But the problem is not just visual. The Sun is a noisy neighbour. It is constantly screaming out radio waves and shooting out a stream of charged particles known as the solar wind. When a spacecraft like a rover on Mars goes behind the Sun, this solar wind acts like static on a radio. It garbles the messages. The mission control teams on Earth often have to stop sending commands, entirely simply waiting in silence until the planet or the ship emerges from the other side of the star. It is a period of anxious silence. The detectives stereo. A and solar orbiter. Human curiosity, however, does not like to take no for an answer. We do not like having blind spots. To solve this problem, scientists realized that if we cannot see behind the Sun from Earth, we need to move our eyes. We need to change our perspective. This is where two incredible pieces of technology come into play, the Stereo A satellite and the solar orbiter. Stereo. The side eye of the solar system. Think of how your eyes work. If you close one eye, you lose your depth perception. You see the world flat, but with two eyes spaced apart, you see in 3 dimensions. For a long time, Earth was like a cyclops, a one-eyed giant staring at the Sun. We could only see the face of the Sun that was looking right at us. The Stereo mission changed that. NASA launched 2 observatories, Stereo A and Stereo B, to drift away from Earth. Stereo A moved ahead of Earth in its orbit. This gave us a side view. When a solar storm erupts on the side of the Sun facing away from Earth, we would usually be clueless. But Stereo A acts like a scout. It can see around the curve. It allows us to track the solar wind and explosions before they even rotate into our view. It turns the unknown into the known. Solar Orbiter, the daring explorer. If Stereo A is the scout watching from the side, the Solar Orbiter is the daredevil getting up quick. A collaboration between European and American space agencies, this satellite does something very special. It tilts its orbit. Most planets and satellites orbit the Sun around its middle like a belt. Solar Orbiter is designed to lift out of that belt. Its goal is to look at the Sun's poles, the top and bottom. This is a huge deal because the poles are hidden regions we rarely get to see clearly. By getting closer to the Sun than Mercury, an enduring heat of several hundred degrees Celsius solar orbiter peers through the glare to show us the chaotic, beautiful magnetic webs that control the solar cycle. It does not just watch the light, it samples the wind, tasting the atmosphere of the star. The cosmic game of hide and seek. Now let us step back from the engineering and look at this through a softer lens. There is something playfully frustrating about the universe. It loves to play hide and seek. We often think of space as a place of darkness, but in this case it is the light that creates the mystery. It is a reminder that too much of a good thing can be blinding. The Sun gives us life, warmth and energy, but it also demands its privacy. It creates a shadow made of light, a sanctuary where comets can sneak by unnoticed and where planets can hide for weeks. This game requires us to learn a very difficult lesson: patience. In our modern world, we want instant connection. We want to text a friend and get a reply in 3 seconds. We want to see a live video feed from Mars without interruption. But the solar conjunction forces us to pause. When Mars hides behind the sun, the most brilliant scientists in the world can do nothing but wait. They must trust that the rover is safe. They must trust that the mathematics of the orbit are correct. It is a humbling experience. It reminds us that we are not the masters of the solar system. We are just guests. The sun is the conductor of this orchestra, and when it demands silence, we must be silent. The beauty of the hidden. There is a specific beauty in these moments of observation when we finally see what was lost. When a spacecraft re-emerges from the glare, sending a beep back to Earth, there is a collective sigh of relief. It is like a diver coming up for air. The work of Stereo A and Solar Orbiter teaches us that if you want to understand the truth, you cannot just stand in one place. You have to move. You have to look at the problem from a different angle. If the light is blinding you from the front, you must move to the side. If the solar wind is too loud, you must build better ears to listen through the noise. This segment of our journey is about the dance between the visible and the invisible. We have learned that a shadow is not just a place where light is absent. A shadow can also be a place where the light is so intense that it washes everything else away. We build these machines not just to collect data, but to satisfy our need to know what lies in the forbidden zones. We want to see the back of the sun. We want to see the storms before they hit us. We want to win the game of hide and seek. As we continue to watch our star, we realize that the shadows are just as important as the light. They force us to be clever, to be patient, and to appreciate the view when the curtain finally lifts. The hidden things are often the most valuable, waiting for the right moment and the right angle to reveal themselves to us. In the world of modern science, few topics are as heated or as fascinating as the search for life beyond Earth. For decades, this subject was pushed to the fringe. It was seen as the territory of science fiction movies or conspiracy theorists. However, in recent years, the conversation has shifted dramatically. At the center of this shift is a man named Avi Loeb, a physicist from Harvard University. His approach is not about wild guessing, it is about a strict demand for one-thing data. The demand for high-quality evidence. Avi Loeb has become a leading voice calling for a change in how we look at the sky. His argument is simple but powerful. He believes that for too long the scientific community has ignored unidentified aerial phenomena, UAP, because they were afraid of being laughed at. When the government or the military releases a video of a strange object, the image is often blurry, grainy, or taken from very far away. Loeb argues that this is not enough. You cannot do real science with a blurry video. To solve this, Loeb founded the Galileo Project. The goal of this project is not to look at old government files or secret documents. Instead, the goal is to collect new, fresh data. He wants to build a network of telescopes and cameras on the rooftops of buildings around the world. These instruments will watch the sky 24 hours a day. They will record everything in high definition. The philosophy here is that extraordinary claims require extraordinary evidence. If we are going to say that an object might be technology from another civilization, we need more than a story from a pilot. We need numbers. We need to know the speed, the trajectory, the heat signature, and the material composition of the object. Loeb insists that we must move from anecdotal evidence stories people tell to scientific evidence measurements we can test. The spirit of science transparency over secrecy. This brings us to a core conflict in this debate, the difference between government secrecy and scientific transparency. Governments and military organizations naturally want to keep secrets. If they see something strange in the sky, their first worry is usually national security. Is it a spy drone? Is it a secret weapon from another country? Because of this, they classify the data. They hide the radar logs and the high-quality videos. Science, however, cannot function in the dark. The true spirit of science relies on transparency. In the scientific method, you must share your data with everyone. You must let other scientists look at your work, check your math, and try to prove you wrong. This is called peer review. If the data is hidden behind a top-secret stamp, science stops. Avi Loeb argues that the sky belongs to everyone. No government owns the view of the stars. Therefore, if there is something flying through our solar system or our atmosphere, the data about it should be public. By keeping the data open, we allow the smartest minds in the world, not just those with security clearance, to analyze the problem. This transparency is the only way to find the truth, whether that truth is boring like a bird or a balloon, or earth-shattering like an alien probe. curiosity and the trap of prejudice. Why has it taken so long for scientists to take this seriously? The answer lies in human psychology. We often think of scientists as perfectly logical robots, but they are humans too. They have egos and they have fear. For a long time there was a stigma attached to UFOs. If a young astronomer wanted to study strange lights in the sky, they risked ruining their career. This is where the concept of open-mindedness becomes essential. Being open-minded does not mean you believe every crazy story you hear. It means you do not reject a possibility just because it sounds strange. Loeb often points to the history of science to prove this point. Long ago, the astronomer Galileo Galilei said the Earth revolved around the Sun. At the time, everyone knew the Earth was the centre of the universe. Galileo was punished for his ideas. Today we know he was right. Loeb suggests we might be making the same mistake today. We assume we are the only intelligent beings in the universe. We assume that if aliens existed, they would have landed on the White House lawn by now. But what if we are wrong? What if they are just passing by, like the object named Oumuamua that passed through our solar system in 2017? It was long, thin, and moved in a way that gravity alone could not explain. Many scientists said it was just a strange rock. Loeb asked, what if it is a broken piece of technology like space junk from a distant civilization? His point was not that it definitely was aliens. His point was that we should be curious enough to check. We should not let our prejudice, our feeling that aliens are impossible, stop us from looking at the data. True curiosity means being willing to be surprised, the relaxation angle, making peace with the unknown. Now let us step back from the telescopes and the arguments. How does this affect us, the regular people living our daily lives? Thinking about life beyond Earth can be intense. It can make us feel small or even scared, but there is a relaxing way to view this debate. It invites us to practice a very special kind of mental peace, the acceptance of the unknown. In our modern world, we are used to having answers instantly. If you want to know the weather, you look at your phone. If you want to know the capital of a country, you search the internet. We have become uncomfortable with not knowing. The debate about open minds teaches us to be comfortable with mystery. We do not know what is out there yet, and that's okay. There is a certain beauty in realizing that the universe is still full of secrets. It means the story is not over. It means there are still adventures left to have. The humility of human intellect. Finally, this topic brings us a great sense of humility. Humans have been on Earth for a very short time compared to the age of the universe. The universe is about 14 billion years old. We have only had modern science for a few hundred years. To think that we know everything about physics or everything about life in the cosmos is actually quite arrogant. Admitting that we might not be the smartest or the only civilization is a humbling thought. But humility is good for the soul. It takes the pressure off. We are just one part of a massive, beautiful and mysterious cosmos. When we look up at the night sky, we don't need to be afraid of what we don't understand. We can simply look up with curiosity. We can support the scientists who are fighting for transparency and data, but we can also just enjoy the wonder of it all. We can adopt the scientific spirit in our own lives. We can try to be less judgmental and more open to new ideas. We can accept that sometimes we just don't have the answer yet. And in that space of not knowing, there is room for imagination, for hope, and for the excitement of discovery. So as the telescopes of the Galileo project turn toward the sky, waiting for a glimmer of light, we can wait with them, not with fear, but with a calm, open, and fascinated mind. Imagine for a moment that the universe is not a vast, cold, and empty void. Instead, try to visualize it as a rich, dark, and fertile soil. In this cosmic landscape, the stars are not just lonely fires burning in the night. They are glowing flowers in a boundless garden, and in this garden there are busy workers, invisible gardeners carrying seeds from one flower bed to another. This is the essence of the fascinating hypothesis put forward by astronomers like Suzanne Feltzner. It is a concept that changes the way we look at those mysterious visitors, the interstellar objects. They are no longer just stray rocks or wandering asteroids. In this light, they become the galactic gardeners, the ancient carriers of potential travelling across the silence to ensure that life is not a lonely accident but a shared blossom. To understand this, we have to go back to the very beginning. We often think of our solar system as a solitary island sitting alone in a quiet part of the galaxy. But Suzanne Feltzner's research suggests that our sun did not grow up alone. Like most stars, the sun was likely born in a crowded nursery. This was a cluster of thousands of young stars all huddled close together, glowing fiercely in the dust of creation. In such a crowded environment, solar systems were not polite neighbours who kept their distance. They were constantly interacting. They brushed past one another, performing a gravitational dance. In this chaotic and beautiful period, these systems swapped materials. Comets, asteroids and rocks were pulled from the edge of one star system and flung into another. It was a time of great exchange. This is where the idea of panspermia enters the story. It is a big word, but the concept is beautifully simple. Pan means all and spermia refers to seeds. It suggests that the seeds of life are everywhere in the universe waiting for the right place to land. Think of an interstellar object like Oumuamua or the comet Borisov as a cosmic envelope. Inside this rock, deep beneath its frozen surface, lie the basic ingredients of life. We are talking about water frozen into ice. We are talking about carbon molecules, the sticky backbone of biology. We are talking about amino acids, the building blocks of proteins. These are not living creatures yet. They are a chemistry set waiting for a student. When a large impact hits a planet that already has water, and chemistry rocks are blasted into space, these rocks can float for millions, even billions of years. Suzanne Faltzner's theory proposes that during the early days of our star cluster, millions of these rocks were traded between the young solar systems. If early life, even just tiny microbes or the chemical instructions for life, was trapped inside those rocks, it could survive the journey. The rock acts as a protective shield guarding the delicate cargo from the harsh radiation of space. It is like a hard shell protecting a nut. Eventually, gravity pulls this traveller in. It crashes onto a new young world, the heat melts the ice. The chemicals mix with the warm oceans of the new planet, and suddenly the process begins. The garden starts to grow. From a scientific perspective, this suggests that the chemistry of our bodies is not unique to Earth. The hydrogen in the water you drink, the carbon in your skin, the iron in your blood, these are cosmic materials, but the galactic gardener theory takes it a step further. It implies that the biological spark might be shared. We might have chemical cousins orbiting a star light years away, all because a wandering rock acted as a bridge between our worlds billions of years ago. From a relaxing and philosophical angle, this is a deeply comforting thought. It dissolves the feeling of isolation that many people feel when they look up at the stars. We often fear that we are alone in the dark, but if the galaxy is a garden and these interstellar objects are the bees carrying pollen, then we are part of a massive interconnected web of life. We are not accidental tourists in the universe. We are a native species. We belong here. Close your eyes and picture the galaxy as a living, breathing ecosystem. You can imagine these interstellar objects drifting silently through the velvet blackness. They are not lost. They are on a mission, even if it takes them eons to complete it. They are carrying the gift of water and organic molecules. They are the threads that sew the galaxy together. This perspective invites a sense of connectedness. In our modern lives, we often feel disconnected from nature, from each other, and from the bigger picture. We get trapped in the tiny details of our daily schedules. But the story of the galactic gardeners reminds us of our heritage. As the famous astronomer Carl Sagan once said, we are made of star stuff. This is literally true. Every atom in your body was forged in the heart of a dying star. But now we can add a new layer to that poetry. We are not just children of the stars, we are travellers. The materials that make up the life on Earth may have been passengers on a great voyage crossing the spaces between the suns to find a home here. When you look at a flower in your garden, you know it needs soil, rain and sunshine. The Earth provided the soil. The comets and asteroids may have delivered the water, the rain. And the sun provided the light. It was a group effort. The whole galaxy collaborated to create the moment where you can sit and breathe and think. This realization brings a profound sense of peace. It makes the universe feel less like a cold machine and more like a grand unfolding story. It is a story of sharing. One star system shares its water with another. One planet shares its chemistry with a neighbour. It is a slow, gentle process of seeding the dark with the potential for light and life. So the next time you feel small or lonely, remember the galactic gardeners. Remember that the space above your head is not a wall, but a corridor. It is full of traffic, ancient silent stones passing in the dark, carrying messages from one star to another. Life in this view is resilient. It wants to exist. It hitchhikes across the galaxy, hidden in the hearts of comets, waiting for a drop of water and a ray of sunlight to wake up. You are the result of that resilience. You are the blooming of a seed that was planted by the universe itself. The galaxy is not just a collection of rocks and gas. It is a garden, and we are the evidence that it is in bloom. As we reach the final months of the year, the air grows colder and the nights grow longer. We have arrived at a profound transition point in our journey with Saturn. November and December of 2025 represent more than just the end of a calendar year. They mark the closing of a magnificent cosmic window. For the past several months, and indeed the past few years, we have been spoiled by the open, glorious view of the ring system. But the universe is a dynamic, ever-moving place, and nothing stays the same forever. This is the fleeting moment. The observation window is now slowly but firmly shutting. If you look up at the night sky during these final weeks, you are witnessing a rare geometric alignment that will not repeat itself in exactly this way for a very long time. The great planet is tilting relative to our line of sight. Throughout this year, we have watched the angle of the rings decrease, getting narrower and narrower. Now, as we approach the end of December, that angle is becoming vanishingly small. We are getting dangerously close to 0 degrees. In the world of astronomy, this is often about data and measurements, but for us, the stargazers seeking peace, this is a lesson in appreciation. When you look through your telescope eyepiece now, you do not see the wide, distinct halo that looks like the brim of a hat. Instead, you see something much more subtle, almost ghostly. The rings have become a razor-thin line, a delicate stroke of silver paint slashing across the darkness. In some moments of atmospheric turbulence, they might even seem to disappear entirely, leaving Saturn looking strangely naked and round like a solitary pearl without its setting. This visual transformation brings us to the heart of mindfulness. Mindfulness is the practice of being fully present in the now without wishing for the past or worrying about the future. It is easy to wish for the wide-open rings of a few years ago, to miss that dramatic, textbook view of Saturn. But if we cling to what the planet used to look like, we miss the unique beauty of what it is right now. This thin, fragile line is precious precisely because it is so temporary. It is a reminder that the most beautiful things in life are often the ones that do not last. Consider the cherry blossom. People travel thousands of kilometers to see these flowers, not because they are the most durable plants, but because they bloom for such a short time and then fall. Their beauty is tied to their impermanence. The current view of Saturn is our cosmic cherry blossom. It is here for these few weeks in November and December, hovering on the edge of visibility, and then it will change again. To observe Saturn right now is to accept that everything is in flow. It is a practice of letting go. When you set up your equipment on these crisp late-year nights, take a moment to feel the rarity of the experience. The light hitting your retina has travelled over 1 billion kilometers to reach you. It is bouncing off ice particles that are moving in perfect silence, and the angle of that light is creating a view that signifies a turning point in the solar system's cycle. You're watching the heavy, slow breathing of a giant. This is a time for a long goodbye. In our fast-paced world, we rarely get the chance to say goodbye to things slowly. Usually changes happen abruptly, a phone call, a sudden event, a closed door. But the universe moves with a majestic slowness. Saturn has been whispering this goodbye to us for months. It has given us time to prepare. As the rings turn edge on, they are effectively hiding from us, retreating into the shadows. This is the planet drawing the curtains. There is a specific kind of relaxation that comes from accepting this closure. It is the relief of stopping the struggle against time. We cannot stop the planets from moving. We cannot hold the rings open with our will. All we can do is stand witness. There is a deep peace in realizing that you are a small observer of a massive clockwork mechanism that functions perfectly without your intervention. You're not responsible for the movement of the spheres. You're only responsible for enjoying the view while it lasts. In these final sessions, you might find that the image in the telescope is not as impressive to the casual observer as it was back in July or August. A friend might look through and say, "I can barely see the rings," but you know better. You know that seeing them this thin is a privilege. You are seeing the geometry of the solar system revealed. You are seeing the incredible flatness of the ring system structures that are hundreds of thousands of kilometers wide but only perhaps 1 kilometer thick or less. Seeing them edge on is the only way to truly comprehend how impossibly thin they are. It is a feat of natural engineering that defies imagination. As the days of December tick away, try to commit this image to your memory. Not just the visual image, but the feeling of the cold air, the quiet of the night, and the sense of connection to the sky. This specific window is closing. By the time the planet returns to a favourable position next year, the geometry will be different. We are entering a phase where the rings will appear to vanish or be very difficult to see as the sun illuminates them from the side. We are transitioning from the era of the glorious rings to the era of the ghostly orb. So treat these last few nights as a ceremony. You do not need to rush. You do not need to take the perfect photograph. In fact, it might be better to put the camera away entirely. Let your eye be the only lens. Let your brain be the only memory card. Watch the planet drift through the field of view. Notice how the light plays off the cloud tops, which might be easier to see now that the glare of the rings has dimmed. There is a Japanese phrase, mono no aware, which roughly translates to the pathos of things or a sensitivity to ephemera. It describes the gentle sadness and wistfulness we feel at the passing of things, but it is a sadness that heightens our appreciation of their beauty. This is exactly what part 10 of our journey is about. It is about looking at Saturn and feeling that mono no aware. Yes, the show is ending, yes, the window is shutting, but how lucky we were to have seen it at all. Letting go is the ultimate act of relaxation. We hold on to so much stress because we try to control outcomes or keep things exactly as they are. Nature teaches us that this is impossible. Winter comes, leaves fall, planets tilt, rings vanish. When we align ourselves with this flow rather than fighting it, we find tranquility. As you pack up your telescope for the final time in this specific period, do not feel empty. Feel full. You have spent the year travelling billions of kilometres with your mind. You have stood on the bridge of a cosmic ship and watched a giant turn. The window is closing, but the house of the universe remains vast and open. The rings will return years from now, opening up like a flower once more. But that is a story for the future. For now, we simply say, thank you for the view, goodbye for now. The moment was fleeting, but it was ours. As the interstellar traveller Oumuamua fades into the deep darkness of the outer solar system, moving beyond the reach of our most powerful telescopes, it leaves behind something far more valuable than its physical presence. It leaves a silence, but it is not an empty silence. It is a space filled with question data and a profound shift in how we perceive our place in the galaxy. This is the true legacy of the event. It's not just about a rock that tumbled through our neighbourhood. It is about what that rock taught us and how it prepared us for the future. The story of science is often told through the lens of great discoveries, but the spaces between those discoveries are just as important. These are the periods of digestion, reflection, and preparation. When Oumuamua first appeared, we were caught by surprise. We were like people sleeping in a house who suddenly realised a stranger had walked through the living room. By the time we fully woke up, the visitor was already stepping out the back door. However, that brief encounter changed the layout of the house forever. We now know that the door is unlocked, we know that visitors are real, and most importantly, we know that we need to keep the lights on. The most immediate legacy is the data itself. For years, and perhaps decades to come, astronomers will return to the observations made during those few frantic weeks in late 2017. Every pixel of light captured by telescopes in Hawaii, Chile, and outer space is being analysed and reanalyzed. This is the beauty of the scientific method. It is a slow, deliberate digestion of truth. In the past, we might have looked at a blurry point of light and dismissed it. Now we treat every anomaly with a new level of respect. The data tells us that the universe is more creative than we imagined. We thought we knew what comets and asteroids looked like. We had clear boxes to put them in. Oumuamua refused to fit in any box. It did not have a tail like a comet, yet it accelerated as if it were being pushed by gas. It was elongated and strange. It taught us that nature does not follow the textbooks we write. Rather, we must rewrite our textbooks to follow nature. This evolution of knowledge flows like a river. Imagine a great stream of wisdom that has been flowing for thousands of years. Ancient astronomers looked up and charted the stars. Later scientists realized the Earth moved around the Sun. Then we learned about the other planets. Oumuamua is a fresh tributary feeding into this river. It connects our solar system to the vast ocean of the Milky Way. Before this object arrived, the space between stars felt empty and disconnected from us. It was a void. Now we understand that the galaxy is an ecosystem. Materials, rocks, and perhaps even the chemical building blocks of life are constantly being traded between star systems. We are not an isolated island. We are a port city in a busy cosmic ocean. This realization brings a sense of peace and connection. We are part of a much grander design. This legacy also extends to our technology and our readiness. Because we were slow to react to Oumuamua, the scientific community has made a vow next time we will be ready. This is the practical side of the legacy. New programs are being developed to scan the sky more deeply and frequently. The Vera C. Rubin Observatory. A massive camera currently being built will soon scan the entire southern sky every few nights. It is designed to catch things that move, things that change, and things that do not belong. It is a net we are casting into the cosmic sea, hoping to catch the next fish that swims by her. Furthermore, space agencies are planning interceptor missions. The idea is to park a spacecraft in space waiting in a dormant state. When the next interstellar object is discovered, this spacecraft will already be out there ready to wake up and chase it down. We want to snap a photo of the next visitor up close. We want to see its surface, measure its temperature, and touch its skin. This shift from passive observation to active hunting is a direct result of the lesson Oumuamua taught us. We learned that if you wait until the guest knocks on the door to get dressed, you will miss the party. You must be dressed and waiting by the window. There is also a deeply human aspect to this legacy. The debate surrounding Oumuamua, was it a hydrogen iceberg? Was it a dust bunny? Was it artificial, sparked the imagination of the public? It reminded everyone that science is not a finished book. It is a mystery novel that we are still writing. It showed young students that there are still major discoveries to be made. A child looking through a telescope today might be the one to command the mission that lands on the next interstellar object. This inspiration is perhaps the most enduring legacy of all. Wisdom is not just facts stored in a computer. It is the spark of curiosity passed from one generation to the next. As we reflect on this, we can find relaxation in the continuity of it all. There is no rush. The universe operates on timescales of billions of years. Oumuamua has been travelling for longer than human civilization has existed, and it will continue to travel long after we are gone. There is a comfort in knowing that we are simply observers watching a magnificent parade. We do not need to control the universe. We only need to witness it and understand it. The confusion and the arguments about what Oumuamua actually was are not failures. They are the growing pains of wisdom. When a baby learns to walk, it falls. When humanity learns about the galaxy, we get confused. It is natural. We are evolving from a species that looked at the ground to a species that looks at the horizon. So we prepare for this next guest. We polish our lenses. We refine our mathematics. We train our computers to look for the strange and the fast. We sit by the river of knowledge and watch the water flow, knowing that the water is never the same. The Oumuamua water has passed downstream, but Oumuamua 2, or something entirely different, is currently tumbling through the dark heading our way. It might arrive tomorrow, or it might arrive in 50 years, but because of the first visitor, we know it is coming. This is a hopeful future. It is a future where we are not afraid of the dark, but curious about what it hides. We have learned that the empty space is full of potential. We have learned that the impossible is often just something we haven't seen yet. The legacy of the Scout is not the object itself, but the open eyes of the humanity it left behind. We are watching, we are waiting, and we are ready to learn more. The journey has been long, but now we have reached the final chapter. We are drifting toward the very edge. The bright, busy warmth of the inner solar system is far behind us. Now there is only the open, silent road ahead. Imagine you are floating alongside our traveller, the Comet Atlas. For months it danced close to the sun. It felt the heat. It glowed with a brilliant tail of dust and gas that painted the sky. It was alive with energy, shedding its layers, changing and shifting under the intense light of our star. But that time of energy and activity is over. The show has ended. The curtains are closing. Now the comet is returning to its natural state. It is becoming a sleeping giant once again. As it moves further and further away, the heat fades. The gas and dust settle down. The long, beautiful tail that once stretched for millions of miles is disappearing, dissolving into the emptiness. It is no longer a bright streak in the sky. It is becoming a quiet, dark wanderer made of ancient ice and rock. Everything is slowing down, just as your breathing is slowing down right now, in and out, slow and steady, and the comet is moving into the eternal night. This is not a scary darkness. It is a peaceful darkness. Imagine the softest, heaviest velvet blanket you have ever felt. That is what space is like here. It is a deep, comforting silence that wraps around everything. There is no wind to push you. There is no sound to disturb you. There is only the perfect, absolute stillness of the void. As Atlas moves away, the sun begins to look smaller. It is no longer a giant ball of fire dominating the view. It is shrinking smaller and smaller until it looks just like another bright star in the tapestry of the night. It is just one point of light among billions of others. This distance brings a profound sense of peace. It reminds us that we do not need to be the center of everything to be safe. The comet does not need the sun's heat anymore. It is content to drift into the cold. The cold here is stable. It is a preservation. It keeps things still for eternity. Think about the position of this comet. It is leaving our home, the solar system, forever. It will likely never return. It is on a one-way ticket to the space between the stars. This feels like a long goodbye, but it's a happy one. We are saying farewell to a friend who is going on a very long, very quiet vacation. As you watch it drift away in your mind's eye, you can feel a sense of release. The comet is letting go of the sun's gravity. It is breaking free. In the same way, you can let go of your day. You can let go of the gravity of your responsibilities, your worries and your thoughts. They cannot hold you anymore. You're breaking free just like the traveller. You're floating into your own peaceful space. The universe is so incredibly vast. It is big enough to hold all things. It is big enough to hold the stars, the planets, the comets, and it is big enough to hold you. You are a part of this giant quiet system. Even though the universe is huge, you're safe within it. You're exactly where you're supposed to be. You're tucked into your bed, a tiny warm island in the middle of the night. The comet is now crossing the invisible line. It is passing the boundary where the sun's wind stops. It is entering the deep ocean of interstellar space. Imagine a ship sailing out of a harbour and into the open sea. The water is calm. The horizon is endless. There is nothing but smooth, dark sailing for millions of years. We watch it go. We do not feel sad. We feel a sense of wonder. We are small, standing on our little blue planet looking up. But even though we are small, our minds can travel this far. We can close our eyes and see the edge of the system. That is a special gift. They are the dreamers of the universe. But now the time for dreaming is shifting into the time for sleeping. The comet is now just a whisper in the dark. It is almost invisible. It has become one with the shadows. It is safe in the eternal night. Nothing can harm it there. It will float in that silence for eons, untouched and undisturbed. I want you to feel that same undisturbed peace in your body. Feel the heaviness in your legs. They are sinking into the mattress just as the comet sinks into the dark. Feel the relaxation in your arms. Your hands are soft and open. Your shoulders are dropping, letting go of any tension. The silence of space is filling your room. It is a protective silence. It acts like a shield, keeping the noise of the world away from you. Inside this shield, everything is slow. Everything is soft. Goodbye, Atlas. Thank you for visiting our neighborhood. Thank you for the beauty you showed us. We wish you a safe journey into the forever. We watch you fade until you are gone. And as you disappear, we turn our attention back to ourselves. We are here, we are warm, we are heavy with sleep. The stars overhead are watching over you like a billion tiny nightlights. They have burned for billions of years, and they will burn for billions more. They have time. You have time. There is no rush to do anything. There is nowhere else you need to be. The eternal night is a friend to the weary. It is the time when the body heals. It is the time when the mind rests. It is the pause between the notes of a song that makes the music beautiful. Allow yourself to drift deeper, deeper into the velvet darkness. It is so comfortable here. The temperature is perfect. The blankets are perfect. You are floating, drifting, floating. The comet is asleep now. The solar system is asleep. The world outside your window is asleep. You are safe in the vastness. You are cradled by the night. Let the image of the stars fade gently from your mind. Let the darkness become soft and warm behind your eyelids. Everything's quiet. Everything is still. Good night, traveller. Good night, world. Good night to you. Sleep. Deep sleep. Forever peaceful. Into the night.